Well, I guess you're my class of 3 people today. I'm gonna start going. Hopefully we get a couple more people added in here. Oh well, it gets recorded, so you guys can hear me okay, right? I hope.
Yeah, I can hear you just fine.
Okay.
Yeah, I can hear you.
All right. Just making sure I'm not rambling away and nobody's nobody's hearing me. But anyway, so now we're getting to more to the tail end of things. After today, we got pretty much 3 weeks left. And I know I start off with a lot of assignments, fast and furious, but like I say, there's a lot of material to cover. Hopefully everybody got through what I think is one of the actual harder assignments in the whole class is that service entrance calculation sheet, just because there's so much to it. But I think going through that, it's a lot of good learning. It reinforces, having to look up details on the building drawings and stuff like that, which is a good takeaway. And it doesn't matter if you're not going to be an electrician. I mean, if you're an HVAC or whatever, you should be able to look at the building prints and be able to determine your electrical requirements based on what you have. And this way you can actually go through it and at least have an educated guess as to what's going on. But like I said, I'll go through them. I'll start grading them today. This one's probably my longest grading assignment, just because there's a lot of detail. And like I say, I'm not gonna kill all of your answers just based on if you didn't get the square footage exactly right, kind of thing. But as long as you follow through all your calculations right and stuff like that, I've never had anybody fail that assignment, so you should all come through it pretty good. Well, like I say, it's one of my more fun ones, just because there's a lot of detail to go through. And so now we're going to go through pretty much we're going to pick up with chapter 7 today, which is kind of a fun one. It's lights and more lights. Yeah, chapter 7. Yeah, luminaires, ballasts, and lamps. And essentially, it's all lights or things that shine. Okay. So, and how are they all different? Well, we'll take a look at that actually. So what's the official definition, right? What's the NEC define a luminaire as? It's a complete lighting unit consisting of a light source, such as a lamp or lamps, and together with the parts designed to position the light source and connect it to the power supply. So there's your official definition. And when you go into, heck, even if you go into like Home Depot, Menards, or, you know, any lighting supply, any electrical supply place or anything like that, what's the most that you see? It's literally hanging on the walls, all on the ceilings throughout the entire thing is a lot of luminaires. There are literally so many different sizes and styles and types of luminaires out there. It's almost insane. You could get lights for just about anything you could possibly imagine, it seems like, I swear. But if you go through the NEC and you want to find out what's like, you know, what's your specific or generic, you know, requirements for installing luminaires, Article 410 has requirements that you would have for, you know, installing luminaires properly. One of the big things, and this is one that I'm sure everybody pays attention to, it's like every fixture has like a maximum wattage rating, okay? Like how much it can safely run within itself. But who actually looks at these ratings when they go and screw in a light bulb? Like, let's say, would you put a 100-watt bulb into a fixture that can only handle 60? People do it. People do it all the time. I mean, is it gonna hurt anything? Well, hopefully not. I mean, it does exceed the rating and stuff like that. You're gonna get more heat than what's intended for that fixture. So hopefully it doesn't cause a problem. But yeah, it's another thing that nobody ever really checks. It's like, well, how many watts can this fixture handle? And that's even just a regular like lamp, okay? Most time what people do is the light bulb burns out, you just grab the replacement and put that in there. But you know, nobody actually checks and makes sure that the rating is what it's supposed to be. But anyway, two types of terms that we'll come across. They have fluorescent and incandescent. Now, fluorescent bulbs are usually the long white cylinder types. They have like they're pressurized. They have a gas inside of them. It gives off what they call an unnatural light. Usually the glow doesn't look quite right to your eyes. It's a little too much into the UV side of things, so things kind of look bluish. Incandescent is natural light. That's like, you know, light from the sun, that kind of thing. So, and that's your natural bulbs. And they come in all the same shapes and sizes that fluorescents do. Basically, you could probably find a shape and size to correspond with each other, whether it's a surface mount, recessed, if you get suspended ceilings, that kind of thing. They have them up for both incandescent and fluorescent. But these are generally the two that we deal with. LEDs typically fall under the incandescent area. Usually it's a natural light unless you get like some kind of colored LEDs, in which case then the light spectrum is going to be a little different. It might not be a natural light. But typically they fall under the incandescent range. So what kind of stuff can we expect to see if we go and look at a luminaire? It should have the number one important, right? Maximum lamp wattage, the type of lamp that it is, the wire temperature rating. So it's like, you don't want to exceed that. That's when you can get insulation breakdown. Whether it's a type IC or non-IC, and that's like a smart lamp kind of thing, where it has like some kind of digital componentry to it or not. So you would have that listed off, boom, boom, and then whether it's suitable for wet locations and whether or not it's thermally protected or not. So this is pretty much a typical rating sheet that you would find on a lighting fixture. whether it doesn't matter what type it is, it should have this. And of course, the fun part is finding it. Where is that? But it should be on there somewhere. So here we have a recess fixture, can lights, if you will, very popular. A lot of people like them. They are a lot bigger. Everybody's usually surprised at how large the recess fixture is, because you never see it, of course, right? All you ever see is the flush mount and then just the little cavity where you would go for with putting in the bulb. But these things are they're cans. They store a lot of heat, so and you can have a lot of heat build up because of course where's the light bulb is underneath and heat rises up, and then you've got an enclosed metal fixture, so the heat buildup can be quite excessive, and they do have rules on this. So if you look at the two pictures, A is correct. This is how you would want to have your, because you got the this is up in the crawl space in your attic area, and you got the fluff installation right there. And notice around this light, it's all clear. You don't have the insulation built up. Now notice in picture B, now this thing's entirely enveloped except for the top. So what's going to happen there is you're going to get, that can is going to start getting a lot of heat build up. And of course, the longer the light's on, the more heat you're going to get. So over time, you know, and you got to remember, this insulation is flame retardant. It's not flame proof. So if you get a high enough heat going onto this thing, it can build up enough where you can cause a fire. So they do have rules for this, like how far, you know, how close to the wall area this thing can be. It can't be butt up on the wall. So you do have to have space requirements, and of course you have to have the space all around this thing. So here it says distance of at least 3 inches insulation must not trap heat. So you have to keep that away and clear. So if you ever do install these very attractive, very popular lights, remember, keep this stuff away. It's pretty much the rule of thumb for this stuff. But so yeah, we have to take care of that the insulation, and you know the fluff is the easiest because it's, you know, it's fluff and you can have it packed in there. If you get the roll style where it's a sheet, usually you cut out. So make sure when you cut out enough area that you are not packed in on top of the fixture like that. So, but NEC has articles on just about everything. So, but if we looked at article 410, section 115, paragraph C, they require an integral thermal protector, an integral like built in on recessed luminaires. And it's just, again, because of the high heat buildup that these types of fixtures can do. And of course, all luminaires must be grounded, and that's according, and again, notice we're all in section 410 here, and this one's in 42A. So there are special requirements for installing luminaires, let's say in your closet area. It has to be completely enclosed, no open lamps, and shelf dimensions. And then there's also special requirements for bathroom installations as well. So we'll kind of take a little look at that. And here we see believe it or not, 3 very popular styles. And each one of those is not allowed. And why is that? Well, so they talk about pendant styles, and that's the type that are hanging on like on a cord. That's not allowed. This type here with no pull chain or anything, that's not allowed. And this type with a pull chain, that's not allowed. And why is that? Because basically you have an open bulb here. So if you were to move stuff around or something like that, you could crack right into the light bulb, shatter the light bulb, you know, and have exposed electricity going on there. Even if you're not there, something were to shift inside of the closet and hit up against that light bulb, right? Instant fire hazard. So these, but surprisingly, these are the 3 the three more popular ones that you will usually find in closets, you generally don't find a light in a closet that has like a dome protector on it or something like that, right? But yeah, believe it or not, these three styles are not allowed within within a closet area. And then they have height specifications for it, how close you're allowed, you know, to the wall or shelf area and everything else. It's like what your dimensions are here. So you have to be extremely careful when installing these things. But yeah, it's just funny. Anyway, now when you do suspended ceiling or drop ceilings, if you will, they're very flimsy. They don't really have any support, right? Generally like some kind of cork board or something like that, hanging suspended on pretty much hanger wire. So it doesn't have a lot of weight support to it. So how do we do it? Well, so you have the lighting fixtures usually flush up with the suspended ceiling, right? But you know you're not going to be able to mount any boxes or anything like that onto it because it'll have a certain amount of weight. So usually what you'll do is you'll run along a 2x4 support and bring in your outlet box like this, and that'll be attached to the hard support, and that's usually what the suspended ceiling is attached to as well. And then you're allowed to do what they call a whip, and basically this is a flex style, and they make these both in metallic and non-metallic, so you can find these in plastic these days, but they're flexible, and you just have to be careful of how far you go with it. As you see here, it can't be over 6 feet, you know, too much grab to it, but you're allowed to whip from the box to the actual suspended ceiling fixture. So the fixture is hanging there, and so that way we don't provide any weight to it. So your main connections and everything are all done up here or within the junction box, but then you bring down and bring your whip in, attach it, and connect your wiring through to the fixture this way. And again, you know, you have to take into account the support of the fixture itself. So usually you'll have that wired up as well. It won't be, you know, the weight of the support will not be on the suspended ceiling. It'll be attached up above, usually to a floor joist or 2x4, something like that. But that's very typical of how we would do this. And my favorites, fluorescents. So how do they all work? Well, incandescents usually have some kind of filament that, you know, it's a high resistive filament. You put current through it and it ends up glowing really, really hot and gives you a certain amount of light to it by how much glow it has. So, and this is considered on warm and natural light. Usually the incandescent style is the style that doesn't hurt your eyes, kind of thing. And they can be used for pretty much any kind of general lighting that you might have, that kind of thing. But yeah, usually it's by a filament, and the filament will glow really bright hot, and that'll give off a light. In the fluorescent style, it's a little different, because usually they have some kind of pressurized gas within a long tube that we're going to energize, and basically the excitation ends up glowing, and that kind of light gives off what they call an unnatural light. It looks strange to the eyes. It's a little off in the spectrum, that kind of thing. I mean, the light is usually very good, but it's not something that you would typically go through and light your house up with, if you will. But if you look at any fluorescent style, what they'll have is something called a ballast. Now, the ballast is usually like a rectangular box that'll be in the fixture. And what it's going to do, it's going to regulate current to the actual fluorescent, the fluorescent bulb, and give it enough voltage to be able to start these lamps. Now, if we didn't have a ballast in there, the fluorescent lamp would go straight to the high voltage power, and basically just based on the way that the gas works, the current would be out of control, and it would start fluctuating all over the place. And usually what will happen is it'll end up tripping your breaker. So they have the ballasts in these things, and generally they're tucked away. You'll have like a metal shield within the fluorescent fixture, and you're able to pop that shield off, and you'll find a ballast, and it'll have like several wires to it. So you would bring incoming power would go to this ballast, and then from the ballast it goes to the lamps. And if you ever do have the pleasure of changing bulbs on these things, very commonly you'll find in most shops that they have replacement ballasts. We used to stock them by the box, because they go out. Basically, it's like a little mini power supply, if you will, tucked up in an area like that. Over time with the heat and whatnot, they tend to go out. So usually it's a pretty straightforward install replacement, right? You go up and change out your bulbs and the light still doesn't come on. Yeah, well, time to change that ballast. And you'll go through and change those out on a very regular basis. Usually if you end up like being a new electrician within like a warehouse or something like that, this will be one of your fun jobs. You'll run around with a scissors lift and go around and change fluorescent lamps and ballasts. I used to load my scissors lift up with a couple of boxes of fluorescent lamps and also a box of ballast, because you'd be up in the air and you don't want to take everything apart to put it back together again, to go down and find a ballast and come back and everything else. But but yeah, fluorescent lamps work with a ballast. The new style they have coming out, which is the replacement ones, where they have like an LED style that fits in the same shape as the fluorescent lamp, but it's not really a ballast per se, but it's in the same shape and size. It's like a little mini power supply for the LEDs, and these are becoming more popular just because they last for so long. Usually you can go about 4 years before you have to change out a bulb. You might have, there's always a fluke where a bulb might be bad and you have to change it out just because it's a manufacturer defect of some kind, but it's pretty rare. Anyway, so to continue on fluorescents do not have a filament running from end to end. Instead, they have a filament on each end. Oh, I got a chat here. Oh, I don't have a chat. What, do you have a baby? Now you're gonna make me pause here. No. Anyway, but yeah, the filaments on the ends are connected to the ballast, and the ballast basically controls the power, controls the voltage, and sizes down the current. Because basically it's going to start an arc on the ends, and then it lights up or energizes the gas that's within inside of it. See, the arc is needed to ionize the gas and vaporize the droplets of mercury inside the lamp. So, and you can see over time that's going to start to degrade. So these things do tend to go out. A little interesting thing is when you do go change out fluorescents, a lot of times people go and just change. Let's say you have 2 bulbs in a fixture, and only one of them is bad. Based on the nature of these things, if you just change out the one bulb and leave the older one in there, I can almost promise you that within a month, you'll be coming back and changing out that second bulb, because now you have this fresh new one, and based on the way these things work with the ballast, now it's going to start overdriving or putting too much current in on that second bulb. So it's a good practice, and I don't know, a lot of shops have adopted this. So if you go up into a fixture and change out one bulb, change out all of them at once. You'll save yourself a lot of time in the long run, and a lot of extra maintenance, if you will, because usually these things are not in a readily accessible area. The very least you're going to get away with is at least some kind of ladder to get up into the ceiling to change out these bulbs. And generally, by the nature of these fixtures, it's always, some kind of opening where you have to flap open the cover and everything else. It's quite a process. Fluorescents can be quite a bit of work, or very minimal work, depending on your maintenance setup. But anyway, I digress. So going on with it, fluorescent lamps do require a ballast operator. So there are, will you shut up, dog? There are several types out there, and it depends. It depends on the application, you know, and they've got types where it's a 2-lamp ballast, 3-lamp ballast, 4-lamp ballast, and so on. You do have to pick the correct one, so it does have to match up with those bulbs to deliver the proper amount of current. They do have preheat types. They have rapid start styles, instant start styles, which is like a pre-charge to it. And believe it or not, even a dimming factor. And these, you don't typically find the dimming one. They are out there. They don't operate very, very well. I mean, you can get them. They are pricier than the normal fixtures and that kind of thing, but anyway. So one thing that did come up when they did do the National Energy in 1992, they did enact restrictions, and one of the things was what they consider a low efficient type lamp. See, you know, fluorescents are considered a high efficiency lamp, and they last a good long time, that kind of thing. But for certain of these factors, they did kick out based on inefficiency. So you may not be able to find these factors for fluorescents available. But and that also applied to like bulbs and things like that. And that's why even a further thing with that nowadays, where now we're getting rid of the old Edison style light bulb, which was what, from the late 1800s design. So you figure, yeah, it's over 100 years old. It might be time to change up and go on with some new bulbs. But here's how we do it. So how can we look at this? You can even actually plot out and see how many hours you would have on your light bulb, okay? So your voltage has a lot to do with it. And believe it or not, an incandescent bulb lasts longer if you were to just leave it on constantly and never ever turn it off versus turning it on and off. Because when you turn it on and off, you're actually taking away the life of your light bulb, believe it or not. I says, so if you look at your amount of hours, but it's that instantaneous flick when you first fire it up, where you get that overcharge of current going out onto that filament, and that degrades the filament over time. And the same when you turn it off, you get that discharge happening, right? That degrades the filament as well. But let's say this thing's working ideally, we don't get any of that kind of thing going on. We go and look, we see 120 volt rated lamp. It's rated for 1,000 hours operating, and notice here at 130 volts versus the 110. Now, very typically, if you go look around your house with your meter, right, you don't have 130 volts. You do have 110 or variations of, okay? So how could we find out? Look at in this case here, if we have this 130 volt one, notice our life here. We say, oh, 353 hours. But if we ran the same bulb at 110 volts on the continuous thing, we can get 3,103 hours out of it. And again, it's the actual rated life, but you're not guaranteed. You know, everything has a limit and a life to it, and it's not always going to agree with your math. But if we were to go through and typically look, and this would be like a formula you could use to see if these are the light bulbs you might want to be using. And you can see it's like, oh, am I going to get enough hours out of this thing? And it's like, if you figure if you had your front room light, let's say on an average you have 3 to 4 hours per day that you use on a front room light, you could plug that through and see how many overall hours or days you would have on that light bulb. Now we take a little look. And this is just a little sidetrack, and this is very, very, very common these days on how we would wire something up with 3-way switches. Now the 3-way is a very, very popular style, just because you can run 2 different switches to the same fixture, if you will. You'll notice in this case we have 2 different lights. Okay, we got a hot line running in, we got a neutral line running in. But here we've got this strange configuration, right? Click, click, click. And really in between, you notice there's nothing there, right? This is just what they call the traveler. And what this will do is basically it travels. It's like an extra wire that you would have that versus just if you had like a regular on-off type switch to this thing, right? In this case, we have 2 points of contact on both sides, but you would have these extra lines with the travelers, and this would be a very typical style how you could wire this up and have 2 different switches. And it doesn't mean that this has to be like a built-in type of light. You know, this could also be used for something like controlling a front room receptacle that you intend to have a lamp hooked up to or that kind of thing. But yeah, we could even have 2 different lights run off of these 3 ways. There's so many different configurations we can look at. But, and that's just to give you a little demonstration of how this looks, because really that's it for this chapter. There's not a whole lot to this. I mean, and I'm sure in the next version, there's probably going to be more information on the LED lights, which are becoming more and more popular. The interesting thing with the LEDs, I mean, they're still gonna be pulling your 110 to each fixture, but each one of those actually has a little power supply to it, because most LEDs are just run on DC power. So you'll have like a little power supply hooked up to these things. In fact, that's one of the first things you'll ever really notice with the LED styles is there's always some kind of weird contraption to it because it has a power supply to it. And believe it or not, the light of the LED might very well outlast the power supply. Which is one of the drawbacks of the LED, is that each fixture does have a power supply to it. So you have that one little extra factor, and basically that's really where most of your costs come in initially, is for LED fixtures, is because of the power supply. And it doesn't matter what style you buy, they're all pretty much built along the same principles. It's just a matter of how many LEDs you have within this thing, and but yeah, the biggest factor for LEDs are the power supplies themselves these days. I don't see any way around that, but the light bulbs themselves do have an average life of like seven years, which is a lot better than these incandescent styles here. And that's why we're phasing out the old Thomas Edison bulbs and stuff like that. I know a lot of people have been crying about like the light bulbs and stuff like that, but seriously, it's an over 100-year-old design, right? Would you drive a car from 100 years ago? Probably not. No. It's like, really look at all most of your inventions and stuff from 100 years ago, and what do we actually still use today? And there's not very much. I mean, we have different concepts of things that they had back then, but yeah, comparatively, we don't use that. So the same with the light bulbs. It's like, yeah, it's a really inefficient old style with the filament literally just burning away to give you light and everything. So going with the LED styles, and they even got the smart bulbs out there and stuff like that. And that's one of the things too, if you notice in that smart bulb, there's always like that little hard plastic area to the bulb or something like that, and that's where the power supply is. They're little, but it does have actual like active digital componentry to it, if you will. And that's what I have for you guys today. Now, if you need to, I went over this a little last time, but pull up something here. So hopefully everybody got through their service entrance stuff. If not, And if they'll let me know, I can extend your times. But we should, okay, for as of today, we should have all our service calculation sheets finished in some way, shape, or form submitted. And like I say, it doesn't matter if you did it like a screenshot or anything like that. And like I said, if you didn't get dead on with the proper square footage of the house, that's fine. And remember, I've had some questions. So for everybody out there, it's like, what house are we using? We're using the house that we have with the book, right? So, and those drawings 1 through 10, which are all of the same house, but that's your square footage for this thing, and pretty much all your information is going to come from those drawings. And again, like I said, with this sheet, page 4 does have all the extra instructions. But if anybody needed more time on this, let me know. I've given you 2 weeks to go through this, and you can see like my highlights in red here are what I consider the most important parts of this all. I mean, it's all important, but as far as installing our servants entrance stuff, like getting our cabinet, our meter socket, and the proper mast piping and whatnot, what all we need would be basically all these highlights in red. And that's the part where I'm going to look at what you did the hardest. But nobody fails this. And like I say, it depends on your square footage and what you compute to be your overall total load here. That's kind of the big one. So as long as you're within the ballpark and everything based on your calculations and stuff, and you give me the proper wire sizes, we should be good to go. Should be. But other than that, let me double check. What do I have coming up for you guys? Well, we're not going to go crazy because we got 4th of July happening. What do I have for today's assignments? We're doing what? We got Uglies quiz number 2, which we got Uglies quiz number 2 assignment for you, and then there's the chapters 5 and 6 quiz. Make sure I don't have both of those should be posted for you. That's all I really have. And then for next time, if you get, reach chapters, now we're going to jump ahead a little bit with 15, 19, and 23. Have some more things that we should go through and cover. But like I say, we're getting to the tail end here. I start off real fast and furious. There's a lot of information that we have to cover. So I want everybody to get comfortable with concepts and whatnot. But that way, when we come up on next Monday after the 4th, we'll go through and we'll talk a bit about special purpose outlets. And that's what these chapters will jump into. And what's like special purpose outlets, and the kind that you would have hooked up to your range or your stove, if you will, your washer and dryer. It could be something like that. And then, so essentially it's like special appliance outlets, the sizes and that kind of thing. Because you get this dedicated circuit that you're not allowed to plug anything else into. So you have this special style outlet that can only accept this style plug. And you'd be amazed at how many different styles they have out there, whether it's a 3-prong, 4-prong, or the variations of those, depending. And it's all based on what kind of voltage, what kind of amperage, so that way you can't mix and match and accidentally damage something. And the only other thing, make sure check the calendar here, but yeah, we got the chapter 7 homework should be done by now. And then, like I say, coming up is the Uglies quiz number 2, and then chapter 5 and 6 homework that I'll have due on Monday. If you guys need time with that, let me know. I know 4th of July weekend and everything kind of kills everything. So if you're not able to get through that, let me know, and then we can extend that out by a couple of days and stuff like that. I'm not going to be getting so much homework and, well, a little bit next week and stuff to close us up, but then by that last week we'll start reviewing things and going over concepts and stuff like that that you should know, and then getting ourselves ready for the final exam. I will have, there's actually 3 Uglies quizzes altogether that we're going to do. So if we're doing Uglies number 2, there'll be one more, and then there'll be a couple more homeworks, and then I'll have everybody seems to like this. I'll have a couple of extra credit assignments that you can do within that last week as well. If your points are a little down or something like that, and you feel like you want to bring it back up, we can use the extra credit assignments. One is an Uglies quiz, like on safety, and then another one is an NEC code challenge where you have to identify based on a picture, identify what the code violation is, and then based on what kind of information you give me on that will be what kind of how many points you get for your extra credit, if you will. But yeah, today's a lighter, easier day. But that's pretty much all I have. Like I say, get through these, get through the chapter 7 homework. And then coming up, we got that Uglies quiz number 2, and then the chapter 5 and 6 quiz as well. But if you guys, like I said, if you guys need more time, just let me know. I know 4th of July weekend, people get crazy, a lot of stuff, well, we'll see how that all goes with all this too, right? But yeah, that's pretty much all I have for you guys today. Do you have any questions or anything, or?
No.
No, I think I'm good.
Yeah, it looks, looking at the grade book, it looks like everybody's doing pretty good overall. I don't try, like I say, there's just a lot of work to this class, but I don't think I like to beat everybody up with it or anything like that. But yeah, let me know, if you have any questions at all, get a hold of me, and then, we'll go over it. But like I say, pretty much the hardest assignment was that service entrance one. We're pretty much through that. But if anybody needs any extra time with that, let me know. Or if you have any questions about that, I think we've gone over quite a bit of it and stuff. But yeah, that's pretty much all I have. Go through those, try to read some of those chapters a little bit, if you will, and then we'll assign some homework for that next week. But otherwise, yeah, you just got those 2 quizzes coming up, and then you should be pretty good to go.
Right.
All right. Well, you guys have a fantastic 4th of July.
You too.
You too.
Don't eat too much. Don't drink too much. No.
I'll try not to.
But have fun. Have fun with whatever you do. Keep it safe out there.
Okay.
You
You
too.
too.
All right. And I'll see you guys on Monday.
Yes, sir.
See you Monday.
All right.